So hello all. So today's problem is longest consecutive sequence. So given an unsorted array of integer nums, we have to return the length of the longest consecutive element sequence. You must write an algorithm that runs big of n times. Okay. So here's the problem. They have given us the nums. We have the number of an array which includes 100, 4, 200, 1, 2, 3. They have asked us to give the longest consecutive sequence. So, how we find out the longest consecutive sequence? So, the number that appears next to each other, right? So, in this problem, in this problem, we have 1, 2, 3, 4. These are the longest and consecutive. Okay, these are longest and consecutive to each other, so this will be included, and we don't want to return the elements. They want us to return the length of that consecutive sequence of elements. So how we will approach the problem, right? We have to in this video we are going to find out better solution, brute force, better solution, and optimal solution. That's all right. So how we will approach this problem? So first, we can say we will take a count, and if we find out the element which is suppose we have current element as 1, and our next element is 2. So if we find out 2 in our array, then we will simply increment the counter. Else we will if we don't find out that 2 in our array, then we will simply keep that 2 as we simply keep the counter as 1. Else we will keep the counter as plus 1. So how we will firstly approach the problem? So here we will take a longest, as we have to find out the longest element, and count as 1. Okay, and we will take a loop. Int I is equal to 0, I is equal to n, I plus plus. Okay, so here if our array of I if our array of I is equal to x, then we will keep the count as 1. And here we will make a while loop. In while loop, we will find out. In while loop, we will simply search. If we will do a linear search here, linear search. In that linear search, we will put our array and x plus 1, and if we get a true from our answer, then we will simply increment the count plus 1, or else we will then we will find out the next element which is the greater than 2. Suppose now we get 2 and we will increment the counter. Then next with the help of while loop, we will search out for the next second next element, right, which is 3. So if we find out the 3, then we will increment the counter which is contain 3, and at the last we will find out math.max between maximum of longest longest between longest and count, and we will return the longest. This is the pseudocode of the brute force. Oh, it is not. Keep okay. So this is the this is the pseudocode for our brute force. So as you see, it's taking us so much time as we are doing a linear search here. Let me put the linear search code here too. How we search a element in our linear search. If array of I, okay, we first take a loop int for int I is equal to 0, I is equal to n, I plus plus. Okay, this is a closing bracket. Yeah. So we will if array of I is equal to x, return true, else return false. Sorry. This is how we do a linear search. Okay. So this is the brute force approach. As here we are getting time complexity as big O of n square. Do we need this solution? We can we make a different solution than this, which is a better solution? Yes, we can. So let's perform a better solution here. So how we approach this better solution? So first we will take a counter as 1, longest as 1, and counter as 1, longest as 1. So we will keep the loop from for first element to the n, and in if loop we will check if array of I is equal to, we will keep a last element as array of 0 last. This is the better solution. So we will keep the last element, which will be the array of 0, and we will simply sort our array. Okay, arrays dot sort. We will sort our array, and what we will get. So if we sort an array, so we will simply check if our array of x, now we will keep the loop from 0 to n. We will check if array of I is equal to array of last plus 1. If both are equal, then we will increment the counter, else we will shift the counter to 1. So can we code that? Yes. So first we will wait. Yes. Let's code that better solution here. Right. So what did I say? We will keep the counter as 1. We will keep the longest as 1. And what else we need? We have to sort our array. Arrays dot sort. And we will sort our array. Okay, and int last element we will keep as nums of 0. Okay, then we will keep a loop from I is equal to 1, as we are starting from 1, because as we are keeping our last element as nums of 0. And here we will keep the length of that array. Okay, so int I is equal to 1, I is equal to n, and I plus plus. So we will do we have sorted our array. So we will check if nums of I is uh, nums of I is equal to last element last element plus 1. Then we as we have planned, we will increment our last element count plus 1, and we will keep as our we need to move forward, right? So we will keep our last element as nums of I. Suppose nums of I is not equal with our last element. So what we will do, we have to write a else condition for it. Nums of I is not equal to last element. So we will simply we can put last element as 1, as we haven't found any uh, the la we haven't found the consecutive value. Then we will reinitialize that with other elements, and we will keep move forward checking the our long consecutive element. So here in longest we will simply mat.max will do a mat.max is equal to longest and count. Okay, and at here we will simply return as turn our longest element. Let's finger cross, let's get checked for, oh, it's get accepted. Yeah, so this will be the boot first approach. The can we optimize it? As we know, as we did a very good job by sorting an element, but as you see, as we have sorted this element, so what will be the time complexity? N log n, n log n, for as we have sorted the element and we are checking through and we have added a loop plus n, so this will be the time complexity. So can we more optimize this? Yes, maybe we can. Let's check. Can we find the optimal approach? So, as one of the approach that comes to my mind is, can we use set here? Yes, we can. So, how we solve the problem this using set? As we know, set only have a unique elements. Duplicates aren't allowed in our set. So can we add all elements in set? If we add, then we will iterate to the set. Okay, you iterate to set using loop, and my approach is that first we will check. Suppose we have we put this into our we put these nums in our array, so in our set, so we will check. Suppose 100 comes, so here we will check if what will be the previous value of 100, so 99. So does 99 exist in our set? Does 99 exist in our set? If we haven't found 99 in our set, then we'll keep move forward. Next we will check 4. So for 4 we will check, does 3 exist? Yes. Then we will check 2 exist? Yes. Then we'll check 1 exist? Yes. So we will simply increment the value as a count is equal to 4, right? As we are checking and incrementing the count value. And next 200 comes in. Okay? We will check, is 199 is in our array? If not, then we will make count as 1 and go to the 1. So if 1 comes, so we will check Is 0 present? No, it's not. So we will make count as 1. We'll move forward and we will check, is 3 exist? uh, as we 2 exist. Yes, and we have already done checking, so we won't check here again. So as and in such a way we will simply found out the count using the set. So how we will solve? So for the code, let's solve this. Okay, so int I is equal to nums dot length, int count would be 1, and int longest would be 1. Okay, so first as per, will keep I is equal to 0, I is equal to n, and I plus plus. We will we haven't initialized our set here, so set integer set is equal to new hash set, as we need to first add all these elements to the set dot add nums of I, as we have added it. So we will iterate to the set is equal to set. Okay, so if set contains, we will simply checking set. If set does not co contains it minus 1, then we can do a one thing, that we will keep the x is equal to it and count as 1. And next we will keep a while loop here, as in brute force search, as we are doing a linear search. So we can replace that in optimal approach. We have replaced that linear search with our uh, we have replace that linear search with our set. So we will check if set contains x plus 1, then we will do x is equal to x plus 1 and count is equal to count plus 1. And over here we will find out the max between longest and count. And one more condition we need to take care, that would be if n is equal to 0, then we will simply return 0. Okay, and here we will return the longest. Oh, int set while set contains x plus 1, here I have solved longest consecutive. Wait, what will be the round? Oh, contains spelling. Wow. Okay, so that's the optimal approach. So in such a way that we have covered this, and yeah, for more You can follow me for more solution like this. You can follow me. Thank you for watching this video.